Hi everyone, welcome to lesson 13 where we're going to practice using the quadratic formula. So in the last lesson, we said that the solution to ax squared plus bx plus c equals 0, any quadratic equation, we can solve by picking off those three coefficients and plugging them into x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we pick off those three numbers, we can substitute them into this formula and it spits back the answers. This is for any quadratic equation set equal to 0. So let's solve these two quadratic equations here. So the first one, it's not equal to 0. Let's fix it. Let's move these terms over. Remember, we can use inverse operations to collect the terms on the same side of the equation. So 2x squared plus 8x plus 3 is 0. So now I can say a equals 2, b equals 8, and c equals 3. And now we just plug it in. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times 2, which is 4. So I took those numbers and I substituted them into the quadratic formula. Then we type in what's under the radical. Don't type in the square root. Just type in 8 squared minus 4 times 2 times 3. And I got 40 over 4. And now comes the tricky part of what do we do? Well, let's look at this radical. Can I simplify it? Radical 40, I can simplify that into 4 and 10, can I? So it's really 2 square roots of 10. So let's split up the fraction. Negative 8 fourths plus or minus 2 radical 10 fourths. So my final answers are negative 2 plus or minus 1/2 radical 10. I simplified these fractions. Remember, the radical you never touch. It's just the number out front. So I got irrational answers to that quadratic equation because the sum of a rational and an irrational is always irrational. Well, this isn't equal to 0, so let's move that 5x over. And make sure you put it in the middle because that's the middle term there with the x when it's written in standard form. So here we go. Give me an a, 1. Give me a b, negative 5, c, negative 14. X equals the opposite of b plus or minus the square root. Make sure you use parentheses when you square b, minus 4 times 1 times negative 14, all over 2 times 1, 2a, which is 2. Type what's under the radical into your calculator. So let's see what we got here. Negative 5 squared. Type in all at once. Minus 4 times 1 times negative 14. I got 81. Wait a minute. I like that I got 81. I like that I got 81 because I know what the square root of 81 is. That's a perfect square. So what that tells me is I probably should have done factoring instead of the quadratic formula, but that's okay because this gives me 5 plus, actually let me do one more step first. 5 plus or minus 9. There's no more square root. I did the square rooting already. I get 5 plus 9, and I also get 5 minus 9. And I get those two solutions. So because I got a perfect square, that tells me my answers are going to be rational, which means I probably should have done factoring and not the quadratic formula from the start. Either way, it works. So know that when you see square roots of perfect squares, you can just type that into your calculator because you're going to get rational numbers. If you get these irrational numbers, you got to be careful and you have a lot more work to do. Solve the following quadratic by using the quadratic formula. Well, it's set equal to 0, so we just need to pick off those three numbers. A equals 3, b equals 4, and c equals 8. And our solutions are in the form of x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. 2 times 3 is 6. Type in What's under the square root? So 4 squared minus 4 times 3 times 8. Uh-oh. Why am I saying uh-oh? There's a problem. There's a problem, and it's right here. Hopefully you remembered when we completed the square, this is not a real number. This is not a real number. Why is it not a real number? It's the square root of a negative. We can't do that. We can't find there's no real number whose square root, there's no real number that when you multiply it by itself gives you a negative number back. Because, right, 2 positives make a positive, 2 negatives make a positive. So there's no way I'm going to multiply a number by itself and get negative 80. So at this point, we quit. We say there's no real solutions. In Algebra 2, we come back and solve this problem, but right now we quit and we say there's no real solutions, we're done. I can't solve this equation. There's no real number answers that make it equal to 0. I can plug any number I can think of in for x, and none of those numbers are going to make it equal to 0. All right, well, this isn't so bad. The quadratic formula is not awful. Solve this using the quadratic formula. Okay, a equals 1, b equals negative 2, and c equals 1. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times 1, which is 2. Why is he still singing? I think he's lost his mind in the quarantine. Oh, I got 0 when I type this in. I got 0 over here when I type that in. So x equals 2 plus or minus x equals 0 over 2. Well, wait a minute. What times itself is 0? Well, 0. So this is really 2 plus or minus 0. Well, 2 plus 0 is 2. 2 minus 0 is 2. So notice you got x equals 1. We did all that work to get x equals 1. So was this the most efficient way? No, we could have factored this. Watch how fast I can factor this and be done, and not have to do any of that work. What multiplies to 1 and adds to negative 2? Well, negative 1 and negative 1. What multiplies to 1, 1 and 1, they're both negative. Using the zero product property, I get x equals 1, and I'm done. Factoring was much faster. Factoring is sometimes faster. They'll get the same answer. We got x equals 1, but it's faster. So this is a big idea that we just saw. How many real answers can you get? Normally when we solve quadratic equations, we get 2 real solutions. Normally we get 2 real solutions because you have the plus version and the minus version. In this last example, how many answers did we get? We really just got 1. We got 1 real solution in this last example, 1 real solution. It's repeated. It's the same number. It's x equals 1 and x equals 1. So there's really 2 answers, but it's one number because you get the same number twice. And then in this problem here, how many answers did we get? We got none. We quit. We could have no real solutions is another option. So right now, this is all that we know about this is a huge idea about quadratics, actually. When you solve a quadratic, we're expecting 2 answers. Sometimes the answers are the same, so it's 1 answer in the end. Or there's these cases where we have no real solutions and there's nothing we can do. So that's what can happen when we solve a quadratic equation. That's when you get the square root of a negative number. When you get the square root of a negative number, that's when you end up with no real solutions. I'm just sliding ahead here to see what I've got. I think I'm going to let you guys try the rest of this lesson. Actually, I have to do that one. Try the rest of this lesson, and I'm not gonna make a video for this because it's just plugging into the quadratic formula and cleaning it up. So you guys try this lesson, try these problems. I'm gonna jump to 5 because I want to show you how to use your calculator. But other than that, these problems here are just using the quadratic formula and practicing cleaning them up. So I'll post answers to those. I'm not going to spend time in the video doing that for you. So let's jump to number 5. Grab your calculator out, and I'm going to show you how you can solve this quadratic equation rounding your answers. So to use the quadratic formula, is it equal to 0? It is. So all we have to do now is plug in those numbers, A, B, and C. I know they're big, and I can actually take out a GCF here to make my life easier, but let's say we didn't realize that. The quadratic formula still works. So t equals the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. And notice here it says round your answers to the nearest tenth. That means use your calculator. I actually like when it says this because at this point, I'm just going to pick up my calculator and type this entire monstrosity in. So on your calculator, alpha, y equals enter makes you your fraction. And we just start typing. X equals negative 20 plus, let's do the plus one first, the square root of 20 squared minus 4 times A times C all over 2A. And I hit enter and it's going to give me a decimal representation. So it says round your answer to the nearest tenth, 1 decimal point. I look at the next guy, so I got negative 1.4. Do I chop or round up? I'm going to chop it right there. So I get t equals negative 1.4 or t equals, let's do it again. But watch this, I'm going to be lazy. I'm going to copy and paste that. I scrolled up and hit enter. I'm going to go back because that was x equals negative b plus the square root. Now I'm going to do minus the square root and get another solution. Nearest tenth, do I chop or round up here? 2.65, I'm going to actually round up to 2.7. T equals 2.7. So notice, we like when it says nearest tenth because you get to use your calculator. You plug the numbers in and you're done. You let the calculator do all the work. However, most of the time though, and like for the problems I'm leaving you with, it says simplest radical form. That means no calculator. You cannot use decimals. No calculators. You gotta do your work. You gotta do your work out and do everything that we've been doing. So it's a little treat. If you see round to the nearest tenth, plug it in and then type it in. All right, guys, I hope you feel good with the quadratic formula. I hope you've been singing it because you got to get it into your head somehow, and that's the way you're going to remember it forever. When you're in college doing math again, you're going to be like, oh, there's Mr. Hines and his quadratic formula. So I'll see you guys soon, and we're almost done with this unit. We're basically done learning everything. We're going to put it all together in the next lesson.